Welcome to this last problem section in this chapter. It's on parametric equations. And here's what we're supposed to do. For x equals sine t and y equals cosine t, eliminate the parameter t and then graph. And as usual, I'll be doing all these four problems here, and then I do them all at once on the graphing calculator and insert the graphs later on. Okay, so let's see. As we did in the lecture before, the easiest way to get rid of the parameter t is by graphing everything, by squaring everything. So we're going to have this one. So square everywhere. Right there, right there. Square all sides. And then add left and right sides. And when we do that, on the right hand side, sine squared plus cosine squared equals 1. On the left side, we're going to come up with x squared plus y squared equals 1. And of course, we recognize that this one is a circle. We recognize this one as a circle, which actually served as our unit circle a few chapters ago. Okay, next example. So this one, once we graph it, will be a circle. Circle with center at 0, 0. The next one, pretty similar. So we're going to square everything. Again, that takes a little bit of typing here. And then, of course, this will be a 9, and this will be a 9. And then we add the left sides and the right sides. On the right sides, 9 cosine squared plus 9 sine squared, of course, comes out to 9. And on the right-hand side, I got a square there. On the right-hand side, we again get x squared plus y squared. And while the first one had a radius of 1, I've got to write that down here with radius 1 and center 0, 0. This one here has a radius of 3 and is still centered at the origin. Okay, the next one. Let's see, square everything. This one, of course, is a 4, and this one is a 16. Oops, I keep forgetting to put the square on the y. Now here we have to first divide by 4 over here, and we have to divide by 16 over here, so that we get a sine squared on the right-hand side and a cosine squared on the right-hand side. We can add them nicely to become a Pythagorean theorem, because otherwise we just can't do it. We cannot add. We could add 4 sine squared to 16 cosine squared, but that only gets rid of 4 of the cosines, and we're left with another 12 cosine squared. So we have to divide first by the 4 and the 16. So divide by 4 equals divide by 16 equals. And at this point, I'll actually be using the equation editor. It'll take a while to type, but I'll be able to recycle it for the next problems. So what we're going to have here on the right-hand side, sine squared plus cosine squared equals 1. And on the left-hand side, we're going to have x squared over 4. So x squared over 4 plus y squared over 16. And that, of course, is a parabola. centered at the origin parabola ellipse. So this one is an ellipse with long and short axis of 2 and 4 respectively. And centered at 0, 0. This one here comes out to a circle again, so we get the 2 and the 3 over to the other side. So we're going to subtract 2 here. Let's see if I can borrow a minus somewhere. Is there any minus available here? Gee, nowhere inside. There it is. So I subtract 2 on both sides, of course. And subtract 3 on both sides. Okay. And then we square both sides. And then we add everything here. So we're going to have parentheses squared plus parentheses squared equals, there it is. On the right-hand side, we come up with sine squared plus cosine squared equals 1. And on the left-hand side, this one here is squared. And this is squared. And the two are added to each other. And we have a circle. Let's see, a circle with radius 1 and center at, let's see, that was 2 and 3. So let's graph them all. Okay, let's see, y equals, the first one we had was, a simple sine t and cosine t. And I may want to look at, do I want to be in degrees or radians? Doesn't really matter. I think I'll be in radians. Window 0 to pi. Scale of maybe pi over 12. So 15 degrees. Previously I must have encountered a scale of 7.5 degrees. X-min, maybe minus 6. I might just do the standard. Let's see if that works. Yeah, let me try the standard. There we go. Ooh, very, very small. For one thing, I'm going to zoom in. There we go. That's better. And then I'm going to use the z standard, z square. There we go. So circle doesn't look that pretty in the graphing calculator because its resolution isn't that great. I'm going to add this here. Let's see, y equals, the next one is simply going to be 3 times cosine. Oh, that was actually switched around. So 3 cosine, whoops, what happened here? Okay, let's start over. 3 cosine and 3 sine. And this one graphed a little bit too big, so I guess I could almost leave it like this here. That's all right. And the next one here will be an ellipse. So we have 2 sine t and 4 cosine t. The graph. Okay, maybe this one I do want to zoom out a little bit. Gosh, maybe a little bit too much. I wish that would look a little bit nicer here. Minus 8 and 8 minus Actually, that almost needs to stay there, minus 8 and 8. Let's see what we get. And then we square this one here. Well, okay, it doesn't look a whole lot bigger. Probably when I zoom in, it's going to be off the screen. Okay, well, never mind, never mind. All right, leave it at this one here. I might come up with a nicer one. Okay, and the last one will again come out to a circle. 2 plus sine t and 3 plus cosine t. And maybe this one here for one thing. Z square, there's a nice circle. And this one here, I truly want to zoom in because it only has a radius of 1. There we go. Okay. All right, let's go back to the problem section. And see what we have in store next. Well, this one here should definitely come up to a hyperbola again. We had discussed that earlier. So square everything. Square, 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 square. And then we're going to subtract. In order to get a Pythagorean, it's going to be secant squared minus tangent squared equals 1. So subtract the first from the second equation. So we're going to have y squared minus x squared there we go, and that will be our hyperbola. With center at the origin. Zero. Okay. Here's a new one, cotangent cosecant. Well, that's also a Pythagorean. Cosecant squared minus cotangent squared equals 1. What might be the difference to the previous one? Well, we already know this one here that it opens sideways. So opening sideways. So we would expect that this one here will be a hyperbola, again with the center at 0, 0, and opening up and down once we're done. Pretty much the same as we did before. Let's see. Yeah, I think I'm just going to grab the whole thing here and grab the square. Put it there. Put it there. Put it there. Have a 9 right here and a 9 right there. Add both. No, don't add both sides, but subtract again the first from the second equation, so that on the right hand side we come up with 9, and on the left hand side again we're going to have x squared y squared minus x squared equals 9. Maybe that's not going to be the same. Maybe we'll see that. Maybe I have to amend that later on. And the last one is going to be this one here. Subtract, of course, 3 on both sides. Again, this will take a while. And then square everything. Square. And let's 25 square. And that's a 25 square. Would have almost fit on there. Okay. And then again we subtract, let's see, the first from the second, I believe it says. Yep, the first from the second in order to come up with an equal 1. And then on the left-hand side, we're going to have y minus 2 squared minus x minus 3 squared. And again, we have our parabola, this time with a center at 3 and 2, and opening sideways, and so that the one in the middle, I might even have to amend that and change it later on to sideways as well. Let's see what we come up with once we have graphed. Okay. So the first one is going to be tangent and secant. So 1 over cosine. Whoops, I said 1 over cosine. Let's see, I'm going to do standard first. Oh, great. Nice, a parabola here. Change this one to dotted lines. There we go. Now we graph. Aha! So the first one is up and down, and that's probably because the tangent and the secant had been switched between x and y. That's my guess. Okay, take this one. Do the next one, which is 3 cotangent. So I'm going to have 3 divided by tangent, and the other one is going to be 3 cosecant. So I'm going to have 3 divided by sine, and we graph. Okay, that one is up and down. And the third one is going to be 5 tangent, 5 times tangent, plus 3. And it's going to be 5 secant, so it's going to be 5 divided by cosine, plus 2, and graphed. There we go. So actually all of them turn out to be up and down. There must have been the tangent and secant must have been switched there. Okay, and with that, I am concluding the problem section for the parametric equations.